Hello guys, my name is Bob. Today we are going to solve the integration of x squared over x sine x plus cosine x squared dx, and we prove it to be equivalent to sine x minus x cosine x plus over x sine x plus cosine x plus c. So this problem itself is quite an interesting problem. There's a lot of solutions online, but usually it is not well explained. So in this video, I'm going to explain how do you prove from here to here. First step, what do we need to do is I will, in the numerator itself, I will multiply by cosine x over cosine x. And the denominator, it will be x sine x plus cosine x squared. Okay, so after which we split this up into two different terms. The first term will be x secant x times the second term will be x cosine x over the x sine x plus cosine x, the whole thing square, and we forgot a dx. Right? Why do we need to do so is because the next part we are going to perform the integration technique called the integration by parts, whereby we identify two terms as, one term as u, the other one as dv, so which is equivalent to, the integral of u dv is equivalent to uv minus away the integral of v du. Okay, so we let u to be x secant x, dv to be this whole chunk. All right, so our u is equals to x secant x, my du over dx is equivalent to secant x plus x secant x tangent x. We know our dv, right? This is equivalent to x cosine x over x sine x plus cosine x, the whole thing square, and then our v is equivalent to the integral of this, which turns out to be negative 1 over the x sine x plus cosine x. So the next question is, how do you actually determine, that the differentiation of v is this form? So we just do a check. So v is equivalent to negative 1 over x sine x plus cosine x. We differentiate with respect to x, so that will give us this answer. Performing the quotient rule, we square the bottom, we bring up this bottom to the top, and then we differentiate 1 minus we keep 1, and then we differentiate x sine x plus cosine x. So if we were to work this out, this is equivalent to my x cosine x over x sine x plus cosine x, this whole thing squared. Right, so back to the question itself, we perform the integration by parts. So integral of u dv is given to u, which is x secant x, dv is bracket minus 1 over bracket x sine x plus cosine x, and then minus away the integral of negative 1 over x sine x plus cosine x du is secant x plus x secant x tangent x. We simplify further, so the first term is negative x secant x over x sine x plus cosine x, so there's a plus c. All right, subtracting away. 2 negative makes a positive, so it becomes a positive. Integration of secant x plus x secant x tangent x over x sine x plus cosine x plus c. Okay, this integral part looks very complex, so the next step I'm going to do is to make it very simple such that the integration is possible. Right. So right now what do I do is that I simplify the top terms into cosine x and sine x. So secant x is 1 over cosine x plus x. Secant x is 1 over cosine x. And then the tangent x is sine x over cosine x over the denominator is x sine x plus cosine x plus c. All right. And then you see, next step we kind of factorize the 1 over cosine square x out in the numerator. So that will give us cosine x plus x sine x, all right, divided by the denominator is x sine x plus cosine x plus c. So now we are able to cancel the numerator and the denominator because they are the same. So now we're left with x secant x over x sine x plus cosine x plus the integration of, we know that 1 over cosine square x is secant square x plus c. And then we integrate secant square x is equals to tangent x plus c plus the negative of x secant x over x sine x plus cosine x. Normally we can stop here, but the thing is that because the question asks us to prove that this is equivalent to this, all right, sine x minus, all right, we need to prove that this is equivalent to sine x minus x cosine x over x plus sine x plus cosine x plus c. So there's some work to do down here. So we have to continue. All right, so this one, we convert the secant x as 1 over cosine x, so it becomes minus x over cosine x, x sine x plus cosine x. The tangent x as sine x over cosine x plus c. So this is equivalent to, the next step we do is to combine two fractions into one. So the first term, it will be just negative x, but the second term in the numerator part, it will be sine x times x sine x plus cosine x. All right, cool. Okay. We expand the numerator out. So there will be x sine square x plus sine x cosine x over cosine x bracket x sine x plus cosine x. So the next thing, because we want to compare from here to here, the answer doesn't have a cosine x. I don't have a cosine x. So what we do is that we need to kind of have a cosine x by factorizing the cosine x out in the numerator part so that we can cancel, and then we get the answer here. What we do is that the next step, we know that from the trigonometry identity that sine square x plus cosine square x is equals to 1. And we substitute sine square x as 1 minus cosine square x. All right, so we got this 1 minus cosine square x. All right, there's an x in front. Plus sine x cosine x over the cosine x, x sine x plus cosine x, right? So this works out to be equivalent to minus x plus x minus x cosine squared x plus sine x cosine x over cosine x bracket x sine x plus cosine x. Cancel the x out because minus x plus x is equal to 0, and then we can factorize the cosine x out. So that will be cosine x bracket minus x cosine x plus sine x over cosine x bracket x sine x plus cosine x. So we cancel the cosine x out, and then this gives us sine x minus x cosine x over x sine x plus cosine x, which we have proven that, from the question, integration of x squared minus x sine x plus cosine x squared dx is equivalent to sine x minus x cosine x over x sine x plus cosine x plus c. That's it from me. Thank you guys for watching, and I will see you in the next integration video.